now I'd like to show you how to work an integration by parts problem which involves a definite integral. So we'll use the fundamental theorem to work it through in the end. So this is how we would do that. The first thing is to perform the integral as is. So here I have the integral from 0 to 2 x times e to the negative x dx. That x times e to the negative x, that product, tells me that integration by parts is probably the technique that I would need to use to integrate. So I'll do that. So we'll start off defining u and dv. And based off of Liate, I've got logarithmic, inverse trig, algebraic, so that will be my u, so the x there, leaving dv to be e to the x dx. And then the derivative here, du would be dx, and v would be negative e to the negative x. Okay, now here's the thing. When I do integration by parts, I end up starting with this part, which is the product of v times u. And that part is technically fully integrated. Actually, that would be a negative. Let me get that in. So negative x e to the negative x. So that part right there, I could actually go ahead and plug in the endpoints 0 to 2 if I like. And that would be just fine. But I still need to integrate this other part because then it's minus the integral of v du. So the integral from 0 to 2 of, well, actually that will turn into a plus because of this negative, e to the negative x dx. So oftentimes I'll just wait to evaluate this until I have everything integrated first. I think that's the easiest thing, just to keep stuff organized, because a lot of times you'll also run into the situation where you have common factors that can factor out, and you can simplify things, and the calculation is easier done in the very end than in between. So I'll just leave it for now. Negative x e to the negative x evaluated from 0 to 2 plus then integrating e to the negative x, oh, that's going to switch to a minus. So let's just make that minus e to the negative x, and then still evaluated from 0 to 2. But that really means that this whole function, negative x e to the negative x minus e to the negative x, everything's going to get evaluated from 0 to 2. So that's why I like to try and wait until the very end. Because as you can see, there's also some common factors that might make things easier. So I could write this as, like, there's a common negative which could pull out, and e to the negative x, and that would leave me with x plus 1 evaluated from 0 to 2. So at this point, let's go ahead and plug in the endpoints and use the fundamental theorem to get our final answer. So e to the, or negative e to the negative 2 times 2 plus 1, right? Then minus negative e to the negative 0 times 0 plus 1. All right, what can we simplify? So this is going to be negative e to the negative second times 3. E to the 0, be careful there because that's not 0. E to the 0 evaluates to 1. Because any number raised to a 0 exponent is 1. And then 0 plus 1 is also 1. So this is actually going to be plus 1 times 1, or 1. All right, so final answer, just cleaning things up, it looks like I have 1 minus 3e to the negative second.